This is lesson number 31 in Algebra 2. Negative reciprocals, perpendicular lines, and remote interior angles. Alright, so you have already done negative reciprocals in the past, but we're going to just do some review. At least I think you have. A negative reciprocal would be taking a number like a fraction, and the reciprocal would be turning it upside down. A negative reciprocal would be as if you change the sign on it as well. So any number that can be written as a fraction, you flip it upside down, and that means you took the reciprocal. If you took negative 6 and did the reciprocal, that would be negative 1/6. So the negative goes with it. Now if I say the negative reciprocal of a number, that means you're going to take something like negative 6 over 1, and the negative reciprocal means you're going to flip it over and change the sign. If I have 3/4, it's positive, negative reciprocal, flip it over and put a negative on it. Okay, so that's it for negative reciprocals. Alright, let's look at perpendicular lines. Alright, so perpendicular lines are lines that cross each other at right angles or 90-degree angles. They cross each other at one point, and if one angle is 90, then all four of these angles are going to be 90 degrees. And what happens is you can write the equation of any line in the whole history of the world, and one of the things that you can determine on whether or not two lines are perpendicular just by looking at their equation is by looking at their slopes. If their slopes are negative reciprocals of each other, then they are perpendicular. So 2 is actually 2 over 1, right? So what we do is we look here and say, is this slope here this reciprocal? Did we flip it over? Yes, we did. Is it the negative reciprocal? Is it negative here and positive here? Are they different signs? Yes, they are, so therefore they're perpendicular to each other. Okay, so that's pretty much it as far as being able to recognize if they're perpendicular. Now let's look at example 31.1. Write the equation of a line that is perpendicular to the line 2/5 x minus 3. So there's one line. They want to know the other line, a line that's perpendicular to it. So they want to know a line that's perpendicular. So if this were the graph of this here, they want to know what the equation looks like for that one, the one that's perpendicular to it. Alright, so that's what we're looking for. So let's go ahead and put our equation back. So y equals 2/5 x minus 3. Alright, one of the things that we know is we know that the slope of this line is 2/5. The negative reciprocal, or the perpendicular equation slope, is the negative reciprocal. We flip it over and change the sign. So we know that part of it. So actually we know that this equation is y equals negative 5/2, the negative reciprocal of the slope, but we don't know where it crosses the y-axis. And remember, in order to write an equation in slope-intercept form, the equation of a straight line, we have to know the slope and we have to know this. Well, we know the slope, so now we have to find this part. What else does the equation say? It says that this line that we're trying to come up with over here, not this one, we don't care about that one, but we know that that line passes through point 3, 2. So wherever it is, it's got a slope of negative 5/2, and it passes through the point 3, 2. So if we were to graph this, and we were to graph this one right here, and let's do it in yellow here, where it crosses the y-axis at negative 3, our slope is 2/5, so up to over 5. Okay, so here is the line of that equation. Okay, so let's look at what we have here. We know that the line goes through point 3, 2, so let's do it in green. 1, 2, 3, 2. So we know it's there, and we know it's perpendicular, so we know it's going to go like this here. Okay, so that's a picture of this line, but what we don't know for sure is this point right there. We know it goes through this point, We know it goes across this yellow line at a 90-degree angle because it's perpendicular, but we don't know where it crosses y, and that's what we're looking for, because where it crosses y is this number right here, my b. So let's see if we can get rid of some of the stuff so that we can do the work. Yeah, I can do that. I'm going to erase all that. Alright, and we said it went through 0.32. Well, what is 0.32? This is the x and this is the y. So how about if we take this equation that has a y, an x, and a b, and let's put the 2 in for the y and a 3 in for the x, and then we could find the b. So 2 equals negative 5 halves x. Oops, no, we're not putting an x in there, are we? We're putting a 3 in there plus b. So 2 equals negative 15 halves plus b. 2 plus 15 halves equals b. And common denominator, so we'll make that a 4 over 2 instead of a 2. And that gives me 19 over 2 equals b. So this is what I'm going to put in there now. So my equation, I'll do this to the left in green, is going to be y equals, I've got my slope, and I've got my b. There's the equation of the line that's perpendicular to that one right there. Okay, so last part of this section is called remote interior angles. And remote interior angles. Alright, let's look and see what they look like. We've got a triangle, and we'll call this point, or this A, we'll call this angle, angle B, and this angle, angle C. And if we extend this line, we get an angle here we will call angle E. So look what we've got here. If we add A, B, and C up, if we add A, B, and C, angles A, B, and C, we get 180 degrees. What happens if we add these two angles together? If we add this angle and this angle, we get a straight angle, we get a supplementary angle, which means we get a measurement of 180 degrees as well. So if these two are equal, then A plus B plus C equals C plus E. Then these have to be equal, right? Alright, so if we have a C here and a C here, we can just cancel that. So I can actually say that A plus B equals E. Now see how maybe that could help you someday. This angle plus this angle equals the remote exterior angle over here. Okay, or I mean, these are the remote interior angles. They're across from our C. And these two added up are going to equal this angle right here. They're not going to equal this one. They're going to equal this angle, which is going to be 180 degrees minus this. So, anyway, there's nothing in this lesson that's going to go over this, but it is kind of nice to be familiar with that, because later on you may need all of that. One of the bits of information that you can go by that too is this angle is angle E as well, because they're across from each other, so they're vertical angles, which means they're going to be equal. So A plus B equals this angle. A plus B also equals this angle. So just something to remember. If it ever comes up, they go over it in this lesson, but there aren't any problems on this that I'm aware of that you're going to run into right now. We'll get into some of that later. So that's it for lesson number 31.